Thanks for the invite to the organizers, and I'm happy to be here. So I'm going to just kind of give you a little bit of an overview of our research center at UMass Lowell, which is about 20 minutes or 20 miles away from Boston, north of Boston. And just kind of give you especially a glimpse at how we utilize additive manufacturing for microelectronics packaging. All right, let's use this one. Okay. Oh, I don't know what's going on here. Okay, let's do this. All right, here we go. Okay. So I'm going to talk to you guys a little bit about our research center and how we're set up, because we do kind of have a unique way that we're trying to advance research in this area. And then I'm going to talk a little bit about the inks that we have available that we make in-house. And then, like I said, a little bit about additive packaging, and then final thoughts in this area. So basically, we have two sister organizations. So the first one is the Raytheon UMass Lowell Research Institute. So we call it RURI. And it's a co-location model with Raytheon. So we are on the 4th floor of an emergent technologies building, and we have 3-4 Raytheon engineers there at all times. So we're constantly collaborating not only on some internal projects, but really going after CRAD projects as well. And really to support that, we also formed what's called the Printed Electronics Research Collaborative, or PERC, which is what comes up on the agenda that you have. And it is a collaborative of companies, majority of them in Massachusetts, to really build the ecosystem in printed electronics. And so this has been a really nice model. A lot of it we do with, we like to do research projects, but there's also different ways that we work with our members, like including Creative Materials, who's here. We borrow or we utilize, sample a lot of their inks, and then if it works, then that's the ink we go with, and then we provide sort of the print parameters to Creative Materials. So. And then other companies like Analog Devices, we're doing some high power applications. So we're testing out some of their newest chips and actually doing the high power testing in their facilities. So lots of different ways, and obviously the big system integrators like RTX, BAE Systems, et cetera. All right, so what are our focus areas? So we do a lot of, obviously, electromagnetic design and simulation, because we really are looking at RF and microwave and going even higher. We have been obviously dealing with 2D, 2.5D, 3D printing. Functional ink development, we didn't set out to develop inks, but we had to because some of the inks that we needed were just not out there commercially. RF devices, antennas, couplers, phase arrays. Printed connectors is another area that we're working on. I'm not going to go into that today. And then advanced microelectronic packaging, printed metasurfaces, especially with textiles. I do have a slide on that just to show. And we also do additive manufacturing for technology protection, and I'm not going to go over that today either. Just a glimpse of the research facilities. We have actually 2 Optimex. This is the 5-axis, so this actually has a UV lamp as well as a laser, an 830 nanometer laser in it. We also have another AJ300. The beauty of the Optimec 5-axis, and you'll see in one of my slides, is it allows you to do conformal printing. The high-rel, we have the end script. We have 2 end scripts. One is the forehead, where you can do the FDM, pick and place, micropen, dispense, and milling. And then we also have one now with the 5-axis. We have a couple of Nordsons. We have a pad printer. I did see a talk on that with Henkel's new ink, and we've been using the Creative Materials ink. So that's an interesting tool that we're slowly trying to implement into RF and microwave. And then we have a characterization specifically really for RF. So we have probe stations, network analyzers. We also do a lot of materials characterization. So looking at materials, dielectric properties, especially loss tangents, up to like 50 gigahertz. So, and we also have a couple of anechoic chambers one that goes